Hey guys, welcome everyone. This is Lab 2, Motion of a Falling Object. My name is Kite Harvey, Group W01, and let's get started. So, as a bit of an introduction, we are going to observe the motion of a falling object, something that falls somewhat slowly, analyze that video in Tracker, and of course, create a computational model. We're going to talk about some things such as Newton's second law, the momentum principle, and a few other things we've been learning in physics such as drag force, terminal velocity, and gravity. We're going to observe the position versus time, also do that in a computational model, and let's get on with it. So to continue this introduction, here are a few images describing Newton's second law, the momentum principle, and friction and drag. First off, Newton's second law can be described as the acceleration of an object as produced by the net force is directly proportional to the magnitude of the net force. In other words, the more force applied, the faster it's going to go, or the faster it's going to accelerate. And also, the acceleration depends on the mass, and the acceleration depends on the force. The momentum principle, on the other hand, is all about collisions between objects. The total momentum of two objects before a collision is equal to the total momentum after the collision, and also the momentum lost by one object can be gained by the other. And lastly, drag can be described as the force that resists an object in motion. And in the case of this experiment, it would be called air resistance. So in my experiment, I decided to take a regular sponge roller, and drop that from a height of about 1.5 meters using a 1.5 meter stick. I initially predicted that my object would fall at around 0.4 seconds after being released from rest, but I didn't really take into account drag or air resistance or surface area or mass of the object. According to my calculations, I thought the final velocity would be around 4.7 meters per second, and that my change in time would be 0.4 seconds, but that was actually significantly less than what it did in the video and my Tracker model. In the model on Tracker, it fell at a little bit over 0.7 seconds, and that's likely due to air resistance and possibly the surface area or shape of the object. To briefly go over my code, my sponge roller weighed about 0.1537 pounds. That's just getting a value off of Google of what a sponge roller would approximately weigh. My roller starts at 1.5 meters, so that's the initial roller dot position vector. I did my change in time at 0.05 seconds. Of course, we have gravity, and I did my change in time on the GlowScript model for less than 0.75 seconds, as that was right after the object came to rest or to the origin. And to update my velocity, I have the roller or the ball dot velocity, which is the force plus the force over the mass times the change in time, and then updated my position, which would be the velocity times change in time. And then I have one arrow going up to represent my drag force, and then I have one arrow going down to represent the force due to gravity. And when those two arrows equal each other, that would technically be when the roller reaches terminal velocity, which we'll talk more about in a second. So terminal velocity can be described as the max velocity possible by an object as it falls due to air resistance, and it equals the drag force equal to the downward force of gravity acting on the object. So what does this all mean? Going back to my initial predictions / calculations, when you neglect the force of drag or air resistance, your object will seemingly fall much faster. But when you do include the drag force and air resistance, it's the force that's, opposing my object. So therefore, it's not going to fall at such a constant and quick rate. What if, on the other hand, if an object was thrown initially downward versus one that was coming from rest, would the terminal velocity be different or the same? I think that the terminal velocity would still be the same, considering that terminal velocity in itself is based on mass and gravity and not how fast the object is going. So if I threw my roller, of course it would reach the ground faster, but I think the terminal velocity would still be the same because the mass of my object isn't changing. However, I think the time that it takes to reach terminal velocity would be different. But all in all, that was my project. I really enjoyed it. Thank you for listening to my presentation. Bye!